Right, so just like we said before, if we want to transform, we must have a basic function. Okay, so this one is a square root function. So if you haven't forgotten, so you can fill in the table of value and graph it out now. Okay, if you forgot, you can look at the previous page. So draw it out. After you finish drawing the basic function, raise your hand. Remember, this is the one that doesn't use the -2, -1, 0, 1, 2. Okay. Raise your hand if you finish the graph of this radical function. Trudy, are you done? Yeah, okay, very good. Right, so the points are 0, 1, 4, 9, right? And then y is 0, 1, 2, 3. So pretty easy. 1, 1, 4, 2, 9, 3. So the curve goes this way. Okay, so we put this up here, so then later on we can compare, right, to see what happens. So for the reflection is like looking in a mirror, right? So you can flip 3 different ways. So let's look at what happens, okay? So the original function, you can box this one, okay? This is the basic. And then the first reflection we have is having a negative over here. Okay, so if I have an extra negative, can somebody guess like what it will do to the graph? How will it change the picture? Yuri, what do you think? How would that negative affect the picture?
It reflects over the x-axis.
Okay, how do you know it's x-axis, not the y-axis?
Because it looks right. It sounds right.
It sounds right. Okay, so we probably need a more general rule. Okay, otherwise later on when you see other questions, when it gets more complicated, right, we need to have a rule. So let's see if it's just like erase said. Okay, if it's really reflect over x-axis. So the best way to find out is plot points, right? So we pretend we don't know which way it reflect, and then use the same points, 0, 1, 4, 9. But then this time we will plug it in and then times it by negative, right? Because there's a negative on the outside, right? So for example, I plug it in, it will be square root of 0, and then times negative, it will stay 0, right? And then next one will become -1, right? Because it's used to be 1, and then you now times negative. So all the y value times it by negative, right? 9 goes in, it will be square root of 9, which is 3, but times negative, so -3. So if we follow the points and then draw, right? 0, 0, 1, -1, 4, -2, and then 9, -3. So this looks like the bottom half of the parabola, right? Remember, we could have a parabola that opens sideways. So the original one is the upper half. This one is flip down, right? Flip over the x-axis. So we call this reflect over x-axis. Okay, so how can we figure this out without drawing the table, right? Instead of, oh, it just feels like it, right? It's not very convincing. So the way I would do is, if anything um, that can be moved to the y side, then it's going to affect the y values, right? If you look at the y value here, the y here, right, on the basic, 0, 1, 2, 3. Now the new y, right, has 0, negative 1, negative 2, negative 3, right? All the y times it by negative. So the y values changed. So let's look at the equation here. If I want to move the negative to the left side, to the y side, how can we do that? Donna? What can we do on both sides so the negative can go to the left?
Divide
Divide.
-1.
Yeah, I can divide both sides by -1 or multiply both sides by -1, okay? So because it's movable, right? The negative is movable. So it will look like y over -1 equals to root x. So anything that's movable to the y side, then it's going to change the y values. Okay, then that will become our first rule. Okay, so we'll say negative with, right? It could be multiply with or divide with the y. Okay, let me rewrite it. Okay, with, I'll write it forward. Negative with y reflect over x-axis. Okay, so this is our reflection rule number 1. Okay, so I would like everybody say together, please turn on your mic. Donna, you ready? Please turn on your mic. Okay, so negative with y, everyone?
Negative
with
y.
Yeah, very good. One more time. Negative with y.
Negative
with y.
y.
Very good. Okay. Reflect over x-axis.
Reflect over x-axis.
Yeah, don't feel stupid, okay? Repeating it, repeating can help you remember and also helps you concentrate. Okay, let's say one more time. Negative with y.
Negative with y.
Reflect over x-axis.
Reflect over x-axis.
Okay, so I do this to every year, right? Every year the student repeat for the important things. So even after 1 year later, and then I ask them, they are able to answer me, even though maybe some of them forgot what it means, but at least it's easier for them to review. Okay, right. So let's look at the next one now. This time we have a negative with the x. Right? And because it's inside the square root, so it's no way you can move it away, right? If I multiply positive, it's not going to affect the negative on the inside. Okay, so if you see a negative inside, you cannot move, right? So this one is stuck, right? You can write can't move to y, right? It's stuck inside the square root. So for this one, if you want to rewrite it, the only way you can do is you write it as x over -1, which is same as negative x, right? You don't have to do that, but it's just showing that no matter where you move the negative, it's gonna be stuck with the x. No way to move it out, okay? So this one, if you have negative with x, what do you think will happen? Kelly?
It will reflect over the y-axis.
Yeah, so by the symmetrical, right? So if a negative with y reflect over x, negative with x reflect over y-axis. Okay. So pretty easy to rule to remember, right? Just say the opposite, right? So let's see if it's really true, right? So let's say if I use the same point, I put 0, 1, 1, 4, right? 9. I put 0 in, right? I'm putting into this one, okay? Into this one. This is the question, right? I put 0 in. Negative times 0 is 0. Square root of 0 is still 0. Okay? What about 1? If I put 1 in, okay? Cindy, what will happen if I put 1 in?
Undefined.
Yeah, you will get -1 and then square root. So I cannot put 1. So the only number I can put is to have a -1. Then that will cancel out the negative, right? So negative times -1 will be 1. Square root that will be 1. Okay? So I need to do the same thing for the 4, right? 4, I need to add the negative. 9, same thing, I need to add the negative. And then the y value will be the same. Okay, so this time it changes the x value. Okay, so original is 0, 1, 4, 9. Now it will be 0, -1, -4, -9. Right? So instead of going to the right side, it will be going to the left side because the x values are negative now. So let's draw it out. Right? So 0, 0. So that point stays. -1, 1. -4, 2. -9, a little bit outside. Right? So goes this way. Right? So this is a reflection over the y-axis, right? Y-axis, this is the y-axis, the middle one, right? So flips to the left side. Okay? So therefore, we got the 2 rules now. These are the most common one, right? So please open your mic one more time. Let's repeat the 2 sentences together. Everybody, Donna, okay, all right. Let's say together, negative with x. Everyone?
Negative
with
x.
x.
Then what?
Reflect
Reflect over
over
y-axis.
Good. I said negative with y. Did I? Okay, let's say one more time. Negative with y.
Negative
with y.
What happens?
Reflect over
x-axis.
Yes. Okay. Negative with x.
Negative
with x.
Yeah. Reflect over y-axis.
Reflect over y-axis.
Yeah. Very good. Okay. Again, negative with y.
Negative
with y.
Reflect over x.
Reflect over x.
Negative with x.
Negative with x.
Reflect over y.
Reflect over y.
Okay, perfect. Okay, when you can do this on your own time, right? This is how you can remember stuff more quickly rather than just looking at it, right? Our memory doesn't work by looking at it. You got to use it, right? Got to say it out and then use hearing, right, to strengthen the memory impression. All right, so let's look at the last one. Let's fill this in, right? This one is reflect over y-axis. And we are all comparing with the basic, okay? The basic is on the top, okay? So by adding negative, we can make it flip different side. And we can also do the same thing for other functions. We have 6 different functions. Okay, let's just test you, okay? See if you can answer a little bit. So for example, I have this one, the absolute value one. Okay, so what does it do? Tiana?
Reflect over y.
Yeah, very good. Okay, we got negative with x, right? Very simple. Now, let's say we have, for the exponential one, let's say we have y equal this. Kelly, what do you think?
Reflect over x.
Why is that?
I don't know, I guess.
You guessed. Okay. Can somebody give us a reason? Is it reflect over X or reflect over Y? Anybody? What will be the reason? If it's movable to the Y, it will be called negative with the Y, right? If it's not movable, then you say it's negative with the X. So is this negative movable or not? I'm falling asleep. Somebody answer. Is this negative movable? Hello, hello. Ring, ring. Nobody knows? Ray?
What?
Huh? Did you hear
Oh,
my question?
it's negative with the y.
How do I move it over?
I don't know, you just move it over.
What can you do on both sides to move it over?
Divide by -1.
Yeah, okay. So this one will be movable, right? So it can be written as -1 at the bottom and then 2 to the x, right? So this is called negative with the y, okay? So Katie, that's the reason why it's reflect over x-axis. Good? Okay, so you have to check. So see if it's movable. If it's not movable, it will be something like this, 2 to the -x. Then that one is not movable, okay? All right, so let's go to the third reflection. All right, can somebody tell me what's happening here? Compare with the basic. What's going on?
X and Y are flipped.
Okay, so X and Y are flipped. Did we see that before?
Yeah.
Okay, where?
Inverse.
Inverse, very good. Okay, X and Y swap. So what will be the reflection then? What kind? How does it reflect?
I don't know.
Does somebody know? Like, remember how the original and inverse, how they will reflect in the graph? You can go back and check, okay? Where is the reflection line?
Y equals x.
Yeah, very good. Okay, y equal x is the diagonal line, right? So this one is inverse, okay? We can write it down, inverse, right? If you ever see an inverse function, coming from original, or you can say, yeah, inverse reflect. Okay, let's put it down here. Inverse reflect over y equals x. Okay, so this is reflect over y equals x. All right, so if you forgot it, go back and look at the inverse section. We did 4 questions, right? Every question we draw the middle line and then show you that it does reflect. Now, how about points? How do we use to get points for inverse? Anyone help us? How do we get points for inverse? If we cannot move on, we will have to stay longer. Come on. You know this. That's why I'm asking. I'm sure you know it. How do we get points for inverse?
We switch the x and y value.
Thank you, Eric. Okay, so x and y swap. So what are the points then? Trudy.
It would be 0, 0,
Yeah, next one.
1, -0.
Yeah.
Wait, is it,
Swap the x and y. Of the original. Where is
1 1
yeah? Next one,
2 4
and then
and then 3 9.
yeah. Okay, so this is the idea of inverse, right? Thank you, Truly. So you just take the original points and then switch x and y. We've done that many times, right? And in your homework too. Okay, so we follow the points and draw it out. 0 0, right? 1 1, 2 4, 3 9 will be here. So this one goes up. Right? If we draw the original one, okay, I'm gonna draw it just to show you. I'll draw it with the dotted line. So it looks like this 2, 4, 2, right? So it goes like this way, right? And then the reflection line is this line, the blue one, right? Cuts in half. This line is y equals x. So that's the middle. The red one is the inverse. The green one is the basic. Okay, so we have 3 reflection here. So let's take a look, okay, an example, how we can apply to questions, all right? So the first question, we have a couple things to do, okay? First, sketch the reflection of the function over x-axis, y-axis, and y equal x, right? Those are the 3 reflections. After that, write the equation, right? So this is the second thing we want to do. What's the equation for the new one? Okay, so that means you need to tell me what's this one, right? Reflection over x-axis looks like that. Reflection over y-axis, right? What's the new equation look like? So the first box here, you see 4 boxes, right? The first box is the basic one. So I remember I asked you to memorize the y equal x cubed. Okay, so I'm gonna ask one of you to draw it out. Okay, who can draw it out? Kelly, have you found out the function, the annotate?
No, I don't think I don't see the setting on mine.
Okay, it should appear for everyone. It's the same program. So maybe later, okay, see if you can find it.
Okay.
Yeah. Cindy, can you draw the basic function for cubic?
For the first cube?
Yeah, first box.
Wait, I don't know if I'm doing this right.
Well, we did it on the previous page, right? Just take a look if you forgot what it looks like. A cubic function, the basic one. What does it look like?
Oh, I don't draw the reflection of it.
No, not the reflection. We're not there yet.
Oh, okay. Never mind.
Let's get the basic, right? This is the equation we're drawing, y equal x cubed.
Nothing.
Yeah, something like that. Okay. Okay, good. Yeah. Let me draw over it. Okay. Here. So make it more skinnier, right? So it goes like that. Okay, you can put on your sheet. Okay, so the next box, we are going to draw the one that's reflected over x-axis. Okay, and the next one we'll draw the reflected over y-axis. And then you have reflect over y equal x. Right, so everybody try it. Draw it in each box. Think about what it will become, right? What it looks like after each reflection. If you are not sure, right, then you can try with points, right? Remember, if it's x-axis, then the negative will go with the y, right? Remember that sentence we repeat so many times? Negative with the y, reflect over x-axis. Negative with x, reflect over y-axis. Inverse, reflect over y equal x. Okay? So please draw the picture for each of the three. After you're done, please raise your hand. Try your best, okay? Don't leave it blank. Just make a guess if you have to, right? Just think about what it might look like. Even if it's wrong, right? You can learn from it.
Are we supposed to write the equation too?
If you know how, yeah, if you finish the graph, yeah, you can start writing the equation. We are going to do that too. But first, we'll go over the graph first. If you finish all the three graphs, please raise your hand. Okay, let's get the x-axis first. Donna, can you help us draw the x-axis one? Okay, pretty fast. Okay, that's good. Okay, it's correct. Very good. All right, so the x-axis you flip upside down. Okay, so it used to be down there, it will go up. It used to be going up, it will go down. Okay, now y-axis. Any volunteer? Y-axis. Okay, Trudy, you are the volunteer, huh? Trudy, can you do the y-axis?
Okay.
We are reflecting the original, the basic. Let me write basic. Okay, so it looks like the same as x-axis then, right? Yeah. Okay, so this one, whatever that's on the right side, it will go to the left, and then whatever on the left will go to the right side. Okay, very good. So this one goes down like that. Okay. All right. So last one, reflect over y equal x. Cindy.
I didn't know how to do this one.
Well, what you can do is, this one is gonna be inverse, right?
Mhm.
Yeah. Okay. How do we get points for inverse? Do you remember?
You like solve the equation for the inverse.
We don't need to solve the inverse. If we know the original table, how do we
Oh,
get?
just flip it.
Yeah, you just flip it, right? Do you know the tables for the original?
Yes.
Yeah, so you can follow that, right? If you really don't if you really cannot just see the shape right away, right? You can follow points, right? And that would be the second way. Okay, try it. Okay, once you've got something, you can draw on the screen.
Something like that.
Something like that. Okay, very good. Just a little bit modification. Okay, so it will. Oops. Okay, let me clear that. Yeah, pretty good. The general shape is correct. Okay, you just need to make it go sideways. Okay, so instead of going up, it will be going to the right. Instead of going down, right, for the original, it will be going to the left. Okay, so that's what inverse does. Up and right, left and down, they are like a pair. Okay, so now our next job is to get the equation now. Okay, so on the top, we'll write the equation for each one. Okay, so the rule for x-axis. What's the rule for reflecting over x-axis? Donna?
Negative with y.
Yeah, okay, negative with a y. So therefore, I can write it as negative y equal x cubed, right? That's negative with a y. But then when you write the answer, you have to isolate y. Okay, so it'll be y equals what, Donna?
Equals negative x cubed.
Yeah, okay. So writing out negative with a y is just helping you to understand what will happen. But the function is always y equal when you want to write your final answer, okay? So if they give you something that's already moved or not moved, right? For example, like first one, then you move it so you can tell what happens. But the answer is always y equal. Okay, so let's go to the second one, y-axis. So what's the rule for reflect over y-axis? Eric?
The negative has to be with the x.
Okay, so how do I write it? How do I put the negative? So negative is stuck with the x.
Y equals bracket negative x bracket cube.
Yeah, okay. So you just use a bracket, kind of like square root, right? Square root is kind of like a box, right? So you draw a bracket, so then you trap the negative with the x, okay? So this is how you can differentiate the two, right? One is without bracket, one has a bracket. Then that way the negative is not movable, okay? Last one, what's the rule for reflect over y equal x? Tiana?
It's an inverse.
Okay, then what will be the equation then?
Is it x3 equals 2 root y?
X, say that again, x
X to the power of 3 equal to root y.
equals to root y, like this?
Yeah.
Okay, do you remember we have 3 steps to find inverse?
Yeah.
Okay, what was the step 1?
Change the f of x to y.
So that will look like y equal x cubed, right?
Mm.
And what will be
And
the...
then you switch the sign or the variable.
Yeah, so what do I write?
X equal to y cube.
Yeah, so this is already the...
Okay.
Right? And then step 3, what would that be?
Isolate y.
Yeah, so how do we isolate the y?
A cube, a root.
Yeah, so I will write cube root of x. Okay, so you can either leave the answer like this one, right, the start, or the second start. Okay, both of them are the same graph. Good? Understand? Okay, so this is the 3 reflections that we could have. We could apply to cubic, right? So of course, we can also apply to the exponential. So this is the second time now, okay? So I guess you know what to do. So start with the graph for the basic. And then please graph the other three, okay? X-axis, Y-axis, and Y equal X. And then get the equation for each one, right? So once you finish all four, then please raise your hand, okay? So this time all on your own now. Exponential. Okay, I will do the basic for you. Okay, the basic is already on the last page. Right, this is the exponential graph. Raise your hand if you finish all the three graphs and equations. Okay.